This lesson is on slope as a rate of change. Our learning goals, we're learning that the slope of a linear relationship has a meaning as a rate of change. So we're still going to be finding the slope, like we just learned how to do, but we're going to include units, and they're going to be questions that involve a rate of some sort, a rate of change. So common things you can think about that have a rate of change are like kilometers per hour, could be our units, okay? Or dollars per hour if you're working, okay? So usually they'll involve, they'll always involve units if you're interpreting it as a rate of change. And then once you've interpreted or you found the rate of change, you can find its meaning. Its meaning will become more obvious. So that's our second learning goal. We can find the rate of change of a linear relationship from a graph or a table of values and interpret its meaning, which is important to be able to do. What does it mean in the context of the question? And again, once you've found what the rate of change is, it's pretty easy to explain what it means. So here's our first example. Hayden is putting money in his savings account each week. Determine the slope of the graph and interpret its meaning as a rate of change. So first of all, just note that in terms of the formula, slope and rate of change are exactly the same formula, okay? And ROC is what we use for rate of change. So if we were going to find the slope of this graph, we would find the rise and the run. And what you want to do is, to do that, you want to find where the line touches a corner, because there aren't points put along the way. So you want to find where does it touch a corner for sure that I'm aware of, and maybe where it's an easy number like 100. So it doesn't matter which 2 points you choose as long as you're for sure where they are, and then you can draw in your rise and your run. So I'm going to go over this way to here for my run, and then from here to here for my rise. And I figure them out the same way. So I figure out the scale of the graph. So along the bottom, we've got like 0.5, so every 2 squares is 1. So when I count out my run, 1, 2, 3, 4, 5. Every 2 squares is 1. So our run is 5, but when we're doing a rate of change, we include units. So in this case, our run isn't only 5, it's 5 weeks, because the units for the horizontal axis are in weeks. So our run is 5 weeks. In our vertical axis, each square represents 10. So when I find out my rise, it's going to be 10, 20, 30, 40, 50. So my rise is 50, but then I have to figure out what are the units for my vertical axis, and it's dollars. It's the amount of money in my account. So $50. Okay, so I've got my rise and my run and my units. So now I just use, to find the rate of change, I still use the slope formula. But this time my rise is going to have units. So $50 over 5 weeks. And then if you divide 50 by 5, you get $10 per week. $10 per week. So again, if we reread the question, Hayden is putting money into his savings account each week. Determine the slope of the graph and interpret its meaning as a rate of change. So if he's putting in money per week, we found out that the rate of change or the slope was $10 per week. He must be putting $10 a week into his bank account. So then we're just going to say that, what its meaning is. Therefore, Hayden puts $10 per week into his savings account. So that's what our rate of change means in the context of that question, that each week he's putting $10 in. Okay? All right. Next one, Michelle spends money from a special account to board her horse each week. Determine the slope of the graph and interpret its meaning as a rate of change. So here you can see we have a negative slope. Because as we go from left to right, the amount in the account is decreasing because she's spending it on boarding her horse. We're going to find our slope, so I'm going to use this point because it's on a corner, and find another nice point on a corner here. Or I could have gone right down to there, it doesn't matter, because the whole thing about a straight line is it has a constant slope or a constant rate of change. So in this case, I'm looking at my run here. It's still every 2 squares is 1. So 1, 2, my run is 2, but I need units. So my run is 2 weeks. And my rise, so I need the scale here. So half of 75. So say I don't know what that is. I'm going to do 75 divided by 2. 37.5. Okay, so each square represents 37.5, or every 2 is 75, one or the other. So if I do every 2 is 75, I've got 75, and then another 75 is 150. So my rise, it's got to be negative, because we're decreasing, 150, and then the units are dollars. So I've got my rise and my run. So now to find my rate of change, ROC, I just use my slope formula. Slope is the rise over the run. And my rise, or my change in the vertical axis, is negative $150. And my run is 2 weeks, which gives me negative $75 per week. And if I want to interpret that, what does that actually mean as a rate of change? It means that she spends $75 each week to board her horse. So therefore, Michelle spends $75 each week to board her horse. Okay, so that is the meaning of a negative slope as far as a rate of change goes, or a negative rate of change. The amount in the account is decreasing because she's spending it on boarding her horse in this case. All right, another example. W, X, Y, and Z represent 4 different drivers who left a rest stop at the same time. Which driver drove the fastest and which driver drove the slowest? Okay, so let's try to interpret what this means. So here we're assuming 0 then represents our rest stop. So this is our kind of where we start at our rest stop. And then over time you can see that in 2 hours, car W has gone 200 kilometers. In 3 hours, car X has gone 350 kilometers. In 5 hours, car Y has gone 450 kilometers. And in 8 hours, car Z has gone 400 kilometers. So I'm just going to attach each car to the rest stop because they all start at the same spot. So I'm going to use green to represent car W. And I'm going to use pink to represent car X. And I'm going to use blue to represent car Y. Oh, sorry, red to be car Y, and blue to represent car Z. So questions like this can be made easier if you remember that the steeper the line is, the bigger its slope is going to be. And the less steep the line is, then the smaller the slope or the rate of change is going to be. So we can just by looking at these 4 lines see that X is the steepest. So that would be the hardest to ski down, okay? It's the steepest slope, which means it's going to be the one that went the fastest. So we know that car X went fastest because it's got the steepest slope. But now we have to find that slope or that rate of change using our slope formula, the rise over the run. So for car X, our run is 2 hours. When our rise is, our run is 3 hours. Not bad. Our run is 3 hours. So 1, 2, 3. When our rise is 350 kilometers, because our rate triangle starts right at 0. So we can use those. Our rise was 350 kilometers, and our run was 3 hours. So our rate of change is 350 divided by 3, which is approximately 116.7, the 6 rounds up, kilometers per hour. So which driver drove the fastest and which driver drove the slowest? Justify your reasoning. So we know that car X drove the fastest because it has the steepest slope, and we know its rate of change was 160.7 kilometers per hour. So that car was driving 116.7 kilometers per hour. And we also know that our slowest driver is car Z. It's the slowest because it's the least steep. And we can find its rate of change the same way by finding the rise and the run. So in this case, the run is going to be 8 hours, and the rise is going to be 400 kilometers. If you read across there. So we have 400 kilometers in 8 hours gives you 50 kilometers per hour. Okay, so we've justified our reasoning, and we found the fastest car and its rate of change at 116.7 kilometers per hour, the slowest car, the least, which is least steep, and it goes at 50 kilometers per hour. All right, now we're going to look at rate of change from a table and still describing its meaning. So OFSA is looking at holding an athletic banquet for badminton. There is a booking fee and a cost per athlete. Determine the cost per athlete. So when you see something like cost per athlete, the per is indicating to you that they want you to find the rate of change, okay? So when they want you to find cost per something, kilometers per something, okay? They're asking you to find the rate of change. So they don't come right out and say, find the slope, find the rate of change, but you have to interpret cost per athlete as being the rate of change. Justify your answer. How can you tell that the relationship between the cost and number of athletes is linear? So there's a couple of things we have to answer here. So I would start off by finding the rises. So from 75 up to 275 is up 200. From 275 up to 475 is up another 200. And so on. And then our run, 0 to 20 is up 20, 20 to 40 up 20, 40 to 60 is up 20, and 60 to 80 is up 20. So the reason we know it's going to form a line is because every time we rise 200, we run 20. So it's got that constant slope, okay? And that slope is also our rate of change. So we can find our rate of change by using our slope formula. So slope or rate of change is equal to the rise over the run. But when we find rate of change, we need units. So these plus 200s are actually costs, so they're dollars. So our rise is $200, and our run is number of people, so it's for 20 people. And 200 divided by 20 is 10, so it's $10 per person as our rate of change. So, and then it asks to determine the cost per athlete. So therefore, the cost per athlete is $10. Okay, so that's interpreting our rate of change there. And then how can you tell that it's linear? This relationship is linear because there is, we say, a constant rate of change. And we saw that in the table because every time we go up $200, we go up 20 people. Every time we go up $200, we go up 20 people. That's a constant rate of change. Okay? And that's how you can tell whether your table is a linear relationship or not. All right, and our last example, a pool is being drained at a constant rate. Determine the rate at which the water is draining from the pool. So here we are asked for a rate. It doesn't say rate of change, but it does say rate. So hopefully you're thinking rate of change. Justify your answer. So we've got our table, so we want to find our rise. And those are big numbers, so remember, if you're not sure, then you subtract the lower from the upper. So 31,500 minus 45,000 is negative 13,500. And then 18,000 minus 31,500 is negative 13,500 again. And then 4,500 minus 18,000 is negative 13,500 again. And those are all liters, since we're finding the rate of change. Those are the units for volume of water. And for our run, we go up 5 hours each time. Up 5 hours, that's our run. So then we want to find our rate of change. So our rate of change, or our slope, is going to be the rise over the run, which is negative 13,500 liters over 5 hours, which reduces to negative 2,700 liters per hour. So determine the rate the rate at which the water is draining from the pool. So therefore 2,700 liters of water is drained each hour. And our justification is showing our analysis of the table and finding our rate of change.